using graphical method for simultaneous equation. In this case, what we need to do is to generate a kind of table of values for the two equations that we have here. And how do we do that? We do that by having a range of value for x. Say let x vary uh, from 0, x is less than 0 and less than, let's say, 4, for instance. Now you need to be careful when choosing the range of value. And one of the ways you know if you are choosing a kind of right frame of value is although there are no if you are going to be given a question in simultaneous question that will be based on graphical method, they might likely state a scale for you to save you a lot of stress. So, but if you are not given a scale, you need to be very careful when selecting the scale. So, what do we have for this particular equation here? We generate a table. This is x, and we have 0, 1, 2, 3, 4, and we have the value of y here. There are several approaches to solving this, and this is one of the approach. So what do we do in this case is that we continue to take the value of x into this equation, 2 into 0. That is when x equals to 0 plus 3y equals to 12. So we have 0 plus 3y equals to 12. Then 3y is equals to 4. Divide both side by 3. 3y equals 12 rather. Divide both side by 3 and y equals to 4. So we have 4 here. We have 4 here. We repeat the same thing for 1. I will just do this for just 2 of the scenario so that you will understand how we do it. So 2 plus 3y equals to 12. 3y equals to 12 minus 2. 3y equals to 10. Then divide both sides by 3. So y is equals to 3.3. So we have approximately 3.3. So we repeat this same procedure for all the equations that we have there so that we can generate the table for both 2x and 3y. So because of our time, I would just do a kind of generate the table automatically so that we can go straight to the plotting. So like I was saying, we are going to generate this table. Then how do we arrive at this? What I did was take the value of x, which is 0, put it here and generate the value of y. Take the value of x, which when it is 1, generate the value of y. And that's the same thing. So for this case, you take 2 and put it here, and you can try that and generate a value. Take 3 as the value, put it there, and I repeated the same thing for the second equation. This equation 1, this equation 2. Second equation also on this side, I take the when x is 0, generate the value of y. So you repeat the same thing for when x is 1. When x is 1, generate the value of y, which is 3. So these are the final tables that we generated. I want you to try that and cross-check your own table with this. Now we'll be going to the graph. When it comes to plotting graph, I'm going to be doing a video on how to plot graph because that requires a little technical skills. So if you're plotting the graph, what you do is just to check what is the highest value, because a graph definitely will have both x and y axis. So what is the highest value on my y axis and what's the lowest value on my y axis? My highest value on y axis is 4 and the lowest value here is 1.3. So that, because that will help you to determine the scale you're going to be using in your graph, and at the same time also lowest value for x. So because we're having we are going to just be taking out an arbitrary graph or chart. In this case, I'll try and ensure that it's perfect as possible. So in this case, we are going to be having 1, 2, 3, 4, and this is, so you can just create this for, you know, x axis, and this is our y axis. So the same thing goes, since we have our value as 4, highest value can go for 1, 2, 3, and 4. So we'll go for this -1, -2, -3, minus 4. So in this case, you have to write the title of your graph, which is the graph of y against x. So you can give us your scale. Let's say if this is 2 centimeter, for instance, 2 centimeter represents 1 unit on the y-axis, and at the same time, 2 centimeter represents 1 unit on x-axis. So now we go to our plotting. So we take the first one. When x is 0, y is 4. This is the 0 value for both x and y. So when x is 0, y is 4. We can use a plus sign. Yes, when x is 1, y is 3.3. When x is 1, y is 3. So let's just assume 3.1, 0.2, 0.3, 0.4, 0.5. So this is 0.3. When x is 1, y is 0.3. So we make this. And when x is 2, y is 2.7. So at the same time, 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is 0.5, and this is 7. Oh, sorry. This is, we're having 2.7 rather. Thank you. So this should be more higher in terms of plotting. So we also have 3. When x is 3, y is 2. This is 2, and this is 3. So we have our, if you're plotting this, you plot it with a very neat ruler. And when x is 4, y is 1.3. This is 4. And 1, 2, 3, 4, 5, 6, 7, 8. So y is 1.3, 1.1, 0.2.3. So we go this way. So we have this. This is just a rough estimate of what we have. So with this, you can generate, you can draw a line. Yes, a line of base fit. So, and you write the equation for this line is 2x plus 3y equals to 12. So that's the case. And the second graph that we have is this: when x is 0, y is 3.5. When x is 0, y is 3.5. So we have, this is it, x is 0, y. So we can use a star for this just to create a difference. When x is 1, y is 3. When x is 1, y is 3. So we have this. And when x is 2, y is 2.5. When x is 2, y is 2.5. You see? So we have something like this. And when x is 3, y is 2. When x is 3, y is 2. Almost the same place with this. And when x is 4, y is 1.5. When x is 4, y is 1.5. So we have this. So if we draw this and we write the equation, which is x plus 2y equals to 7. Now, the solution to this graph is actually the point where these two linear graphs intersect. That's the solution. So we check down what's the value of x when it intersects 3, and what's the value of y when it intersects 2. So we have x equals to 3 and y equals to 2. So that's the solution. Another way you can know this is by looking at your table. Although this is not always an advice, a way that I will advise you to look at where do we have the same value for the table. But the best way to know is through your graph.